Devops and Immutable Infrastructure. I'm actually a director of ecosystem development, which is a fancy term for BD. So why did Sarah invite me up here? Yes, 35 years in IT. Just a quick, why would I be qualified? I like when a speaker at least tells you, because most of you probably don't know who the hell I am. Why I'm up here. And so I started my career in Exxon. I've been IT operations. I am an IT operations junkie. Other than my wife and my kids, that's really all I think about. Maybe sports on Saturdays, but I was early in at Canonical. I was actually the first public cloud was something called Eucalyptus. Canonical tried to OEM that. I worked for Simon Wardley there. I was really early in at Chef. Got to have an amazing experience. You got Chris Brown coming up, who was I am a big fan of, so I'm going to be sitting in the front row listening. And then the startup gods have been pretty good. So what that means is I've had about 30 years of failed startups, but the startup gods have been pretty good to me in the last 3 years. I had a company I sold to Dell called Stratius, and then most recently, 7 months ago, I sold a company called Soccer Plane to Dell. Not to Dell, to Docker. I got a D right. I am one of the original core organizers of Devops. I was the only American at the original Devops days in Ghent 6 years ago. I brought the first conference here in the US. I've been really a big part of that movement, along with a bunch of other people. And I do this DevOps Cafe on iTunes where we interview all the leaders over the years. 6 years, I think we've been doing it. So the agenda here is what is immutable infrastructure, why order matters. So something I think a lot about in terms of how, again, I told you I'm a junkie for infrastructure. Most of my career has been very frustrated at large-scale infrastructure, particularly in the enterprise, not working. The web scale thing over the last 5 or 10 years has been really interesting to watch these cloud scale, cloud titans figure things out that my enterprise brethren and sisterhood could never figure out, right? So we'll talk a little about order matters. We'll talk about models and methods used in immutable infrastructure. I'll talk a little about Docker and how Docker plays in this, but it's generally a container story. There are a couple of things about Docker, and then if we have time, we'll go over some case studies. So I've done this presentation, the third time I've done it. The first time I did it, I spent the whole time, and at the end, some woman came up to me and said, "Oh, John, by the way, what does immutable mean?" Yeah, all right, let's get the dictionary version. But I do want to set the premise that, in our industry, we tend to overload mathematical terms. Now, I'm not a mathematician or a trained classical. I don't get all twisted at the ankles about this. But there are some people and some of my dear friends who think when you use the word idempotency or immutable, or if you're not core to mathematics, think of it more as a metaphoric way of thinking about how we do infrastructure. Now, when we talk about idempotency and things like configuration management, it really isn't mathematically idempotent. It's a checksum most of the time. So one other thing, a dear friend of mine, Mark Burgess, who is really kind of should be credited with this genre of infrastructure code or desired state convergence. He hates the term immutability or immutable infrastructure. So before I gave this presentation the first time, I wanted to sit down and walk through it and try to convince him that he wouldn't think I'm an idiot for giving this presentation. I will agree that when we use the term immutable infrastructure, I'll give at least enough to my mathematics friends and physics folk that there is no such thing as an immutable infrastructure, right? Let's get that out of the way. So if we get past that, we can think about it as kind of a model of how we might want to think about delivery, then I think we can get on with stop fighting on Twitter for 40 pages of tweets about why the term doesn't make sense and why we should use another term. And we see this all the time, DevOps, cloud, why we should use a different term. All right, so what I want to start with, which was a paper by this Steve Churgot back in 2002, and it's why order matters. It's very mathematical, but this gentleman makes a really good point. And when I actually shared this with Mark Burgess, so Mark Burgess is, like I said, the original author of CF Engine. If you know the heritage, Puppet, Luke Knies was a frustrated CF Engine user. Adam Jacob was a frustrated Puppet user, right? So the heritage the lineage is pretty clear. I talked to Mark about this paper, and he said it's kind of funny. He was so ahead of his time. And if you read this paper, it almost screams Docker. And he makes this whole argument of why, at scale, immutable infrastructure works. And the thing here that I think is important about this is that I lost my train of thought. Sorry. Is that he proves out immutability. And let me go here. He makes this argument, or not in the paper. He talks about 3 models. Divergent infrastructure is our classic unmanaged. We build a system when we want to build it. We build it any way we want, right? We get no OpEx value add out of that kind of model, right? And then about 7 or 8 years ago, depending on, I think you have to give Luke Keynes of Puppet a lot of credibility, because the only people that really ran CF Engine prior to Puppet were large universities and companies like Amazon, right? And Luke basically prophesized this model of convergence. Again, very much modeled after what CF Engine had done. I mean, it's funny, I actually learned the products. This is why I get in trouble. I run out of time. I learned the products in reverse order. I learned Chef first, and I thought, wow, those folk at Chef were so smart. They came up with this, this. And then I learned Puppet, and I was like, oh, Luke Keynes from Puppet figured this out. Then I learned CF Engine, and I realized a lot of things that were in all 3 products came from Mark, right? But we've had a good run, and it's not over. I'm not advocating that convergence is done, and it's an end story. But we've had a good run on convergence. We've gotten scalable commerce, scalable infrastructure that's given us unbelievable commerce over the last, say, 5 or 6 years, right? How do you build scalable infrastructure? You build repeatable, buildable infrastructure through an abstraction that is constantly converging. Typically, you run something like on an agent that maybe every 30 minutes or an hour converges back to a state. So you're always converging, diverging, converging, diverging. What Steve Turgot was talking about is congruence, a model that really is congruent from day one and stays congruent, right? And so the question is, if you're building a converged environment, so let's just make the assumption divergence is a bad model, right? But convergence, if you're building infrastructure on a converged model, what is the current at this moment state? What if you have to get to the state that you think you need to be at this moment? There's a high-frequency trading, there's a SaaS-based multi-tenant high-frequency trading company out of New York that runs all on containers. And at 5 o'clock every day, they wipe the system clean and build it up. Now, if you heard me on those acronyms I just used, SaaS, multi-tenant, multi-tenant's not an acronym, and HFT, you would say that's impossible, John. But their customers are Goldman Sachs. At Barclays, there's algorithmic trading algorithm at Barclays that only like 8 people in the company are allowed to have access to. These are the holy grail. And this company's figured out a way to build a bulletproof infrastructure with containers to be able to actually allow companies like Goldman Sachs and a couple other large financial titans to actually use their SaaS for certain HFT infrastructure. So in the paper, the Steve Turgot makes the argument that so here's the thing, right? Convergence requires a level of abstraction of how you build infrastructure, right? So you build infrastructure basically through some language, a recipe or a manifest, some DSL-based infrastructure, and you do things and you build it. So it's kind of I'll get to this later, there's a kind of a bake versus fry argument. Bake is you build up, you kind of start with just enough operating system, and you bake your way up. You throw in the flour or the sugar or whatever you do to make a cake or whatever. And then the fry is you take it out of the freezer and you spray it onto a hot, sizzling frying pan, right? And when you use abstraction, you need to be aware that the abstraction has some things in it that could bite you, especially scale. Does this matter at 100 machines? Absolutely not. Does it matter at 1,000 machines? Probably not. 10,000? Maybe. 100,000? Yeah. You start getting into large-scale infrastructure, larger than that, at scale. In fact, the one thing I forgot to talk about earlier in that paper was, I will say this, when I was at Chef, one of the things I used to do is use that paper as an argument against Puppet. because at the time, and this is not really true now, Chef was a very deterministic structure. You said statement 1, statement 2, statement 3, statement 4 was an include. You ran those statements, you came back to the next statement to build your infrastructure. Whereas Puppet used a dependency graph. And I would tell you, when I go up to people who are running Puppet at scale, at the time, and this is not an issue as much now, the products have, excuse the pun, but have converged to basically be almost the same in general. But at the time, you'd go up to people running scale, and you'd explain this order matters thing, and they'd go, yep. Because you build 10,000 or 100,000 machines, and one of them, the order was just a little different of how it was built. It mattered. And if you don't believe me, go read the paper by a scientist, because it's his argument, not mine. Yeah, and you run into these things like circular dependencies. So one of the arguments he makes, if you're using an abstraction to build infrastructure, so some tool that abstracts to build infrastructure, and you are updating that product itself, and that product is updating the infrastructure, you could have a circular dependency. More likely is there are a set of things you do, right? When you use an abstraction to build infrastructure, you're usually doing primitives for packages or primitives. In fact, more often than not, if you look at most of the abstractions for building infrastructure, it's just a bunch of commands, right? So it always amazes me when you look at like a recipe or a manifest, how much of it is just commands in order. I mean, it's good because it's all in source control, it's repeatable. But the thing is the brains behind those commands are just links to the system calls. And in some cases, you can do 5 commands. The 6th command silently dies, doesn't really break. 7th command works. And that happened only on one system. I was afforded availability I was given the opportunity to see a report by JP Morgan Chase once where they decided they had completely abstracted their infrastructure using one of the 3 tools. And they thought things were good. It was desired state, converged infrastructure. And they just decided to turn the kind of the knob up for how often they check the divergence. Like I said, in most cases, people will run like 30 minutes or an hour to always converge back. In this case, they just wanted to get kind of a view into, they found over about a 3-day period that on average, so they turned it down to some ridiculously low, like 5 seconds or something like 3 seconds, like it was crazy, but they could do it. They found to their amazement, there were 1 billion unplanned changes on their infrastructure a day. And if you ever heard the concept of the butterfly effect, so think playing that out when one thing goes haywire and you're trying to troubleshoot that. And again, that's the core of this man's argument. Right command, wrong order, package, wrong order. There's also a bunch of papers also about even packaging, RPMs and things like that at the same time frame that he refers to. And I'm not proposing anarchy here. I'm just saying that be aware at scalable infrastructure, in my opinion, after 35 years, for whatever that's worth, if I can get a congruent environment, I want one. To me, that's the operating model. And I have a couple of case studies of 2 companies that would show why this. This is where I probably, this is like I should take this slide out. I love Chef. I'm a stockholder, so anything I say doesn't appear to be anti-Chef. And I didn't actually choose Puppet for this example. One of my coworkers, Jerome Pisani, who's the #1 evangelist over at Docker, the only point I want to make about this is be aware. I'm not saying DSL or converged infrastructure or desired state configuration management is a bad thing. It has been amazing for us in our industry. I will say that when you're using an abstraction, and this is what Steve Turgott's paper tries to point out, is there are some pitfalls about using these abstractions. And this is a good example of semantics, maybe education. The example here is I need to install an upgrade to OpenSSH. I put it in, I use in Puppet, there's a primitive called package. I use this parameter called ensure, install, bang, right? For whatever reason, that package fails, or I need to basically do some form of a rollback. I think I can go back to the original installed, and maybe the person who wrote the manifest and the person who now owns it, maybe the person who wrote it completely knew that there was nothing mystical or magical about the package primitive. It didn't go, oh, I I know what exact state you were at when we did this. So I'm going to go back and traverse and get you back to that state. It's a rote slam in. And so this example is the person tries to go ahead and get back to the state. It's not there. Oh, by the way, they can't even find the package that was originally there. Now, this is an argument for bad hygiene or against bad hygiene for infrastructure. But I would say there are models today where this will not be a problem, right? And it is immutable, infrastructure, building artifacts that have everything, cataloging your infrastructure. I had a great conversation when I first got to Docker. I was asked to write a paper, which I'm going to be talking about in a little bit, about Docker and in the 3 ways of DevOps, based on a Gartner report. And I started talking to our customers, and one of these customers had written a pass in Docker. And when he talked about, he said, John, it's kind of funny. I actually have every version of every release, and I keep it forever. And I was like, and then he laughed. He said, yeah, that sounds really stupid, forever. And he said, yeah, but then he caught himself. He says, you know what? I use Ceph on my backend storage, so it is kind of forever. I just add another node. As I stay one node ahead of it, it is forever, right? It really isn't, but it's like the Amazon S3 being forever, right? Like it's kind of a economy. The point is that these abstractions you need to be aware of. The person who is actually implementing and maintaining might not fully understand that primitive is very dumb. A lot of things, infrastructure as code is brilliant. I love, even today when I actually want to try to figure out how to install things of a new product, I go look for a chef recipe to figure out how it's installed, right? But at the end of the day, it is an abstraction, and like a lot of those primitives, in talking about idempotency, in many cases, this magical idempotency of infrastructure as code is really just a checksum. Right? There's no magical thing other than, it looks like when I check this config file, it's different. All right, wham, going to put it in. That's not horrible when you came from a divergent methodology. So these people who do immutable infrastructure, in general, what do they do? And so I summarized, I spoke to a lot of companies that were doing this. This all started because like 2 weeks after I got to Docker, I was asked to write a blog post about a Gartner presentation about how Gartner recommends using Docker for continuous integration and continuous delivery. It's a great paper. Not hard to find. They've only written about 4. You just find the one that says configuration, CI and CD in it, and you're good to go. So as I do, I don't just write a blog article. I go nuts and spend the next 6 weeks trying to write something, the Sistine Chapel version. I started interviewing everybody, and what I came up with really was kind of no crud allowed for infrastructure. Create, replace, update, and delete. In general, the people, and again, mileage varies. Let's think about the immutable infrastructure myth. But in general, this is a methodology that people apply where you're just not going to create anything new on a running infrastructure. Generally production, but it could be a test environment that's quasi-production. You're not going to change your config files. You're not going to update any configuration. Like, you just replace and roll forward, right? And the one caveat the people I talk to would be databases, a little more tricky. Databases are always the tricky ones. I say it's kind of RUD. They actually do, like they'll have a record, they'll create a new one, they'll kind of change the state of the old one to the new one. So here again, keep those records forever, right? So that's basically, everybody having fun? Are we woken up? Is that all right? Good, yeah, general, okay. So how do you do this? It's pretty obvious, but you provision a new server, you test a new one. How many people have read the Continuous Delivery book by Jez Humble? Just a couple, okay, yeah. It's a very thick book, actually, but it kind of is a Bible on how to do continuous integration, continuous delivery. Jez used to work for ThoughtWorks, probably one of the original teams, Chris Reed, Jez, and my mind escapes me, back in 2007, gave a presentation at an Agile conference talking about this model of flow that almost everybody desires to get to today, which is what we call continuous delivery. So it was a groundbreaking 2007. The lineage, you hear things like John Allspar at Flickr doing 10 deploys a day, and starting in about 2008, 2009, in this world that we live in today where people are trying to continuously deploy everything, including Eric Ries's Lean Startup book. But in that book, he talks about some of these models of what's called blue-green deploys. So you have a cluster. You basically pull one node off the cluster. You change the status. I always can't remember if it's green or blue. I think you change it blue. You make the update. You put it back. You grab the next one. You do this, right? So this is kind of a model for immutability. Like you're just kind of always rolling forward, whether it's a large cluster or it's a single system. In general, you don't practice immutable infrastructure unless you've thought about delivering distributed architecture infrastructure. Like you don't take legacy Oracle applications and say, hey, I heard this idiot at Nginx conference talking about immutable infrastructure. Let's go change all that. No, you don't do that. Like it's usually typically greenfield architectures that you're trying to build and change architecture. So you change the reference to the server and you keep the old one back. So here's the thing. I finally got Mark Burgess to accept my argument about immutability. I don't think he'll admit this publicly. So his argument is that it's not immutable, and I use a Java object, immutable objects in Java, because basically you change the object, you change the pointer reference, bang. That's basically what I'm saying we're doing here. We're basically changing the pointer reference to the server that we just swapped, right? It's not rocket science, but when you start putting it all together, it gets kind of, from a geeky ops infrastructure person who thinks about this stuff all the time, it gets kind of rocket science-y. I should have worn my, it's not rocket science, but it was a t-shirt from NASA. And it says, actually it is. That's a good one. And then you keep the server around for rollback, right? And just to think about, to throw the historical aspect of this story, right? I'm very old. There was a time in the infrastructure where every desktop was built with these golden images. Is anybody old enough to remember Ghost, right? Yeah, so, and how did that turn out? Okay, but not well. The industry adapted, and I called it Trombone, right? We're actually always been fighting pro-immutability, con-immutability, And the VDI was basically a reaction to some of that, how to basically do OpEx on infrastructure. Virtualization got really huge. That looked awesome. And again, to give credit due, the industry has benefited heavily from virtualization over the last 15 or 20 years. But we run into problems with image sprawl, right? If we don't have good hygiene for those images, whoops, started the wrong one. That was the development one. Martin Fowler wrote an article, these two kind of, the infrastructure as code genre getting embraced in the wild. Again, I would give Luke Knies sort of credit for, cracking that egg or whatever. But Martin Fowler wrote Phoenix servers versus Snowflake servers, right? So about the same time, Martin Fowler, one of the original Agile Manifesto signers, basically said, what if I could go into a data center with a bat and smash up all the servers and magically build them right back to where they were? And the Phoenix server concept was kind of out of the ashes I could build, right? Which actually, coincides with the whole infrastructure as code movement. First time I ever heard that phrase was at a 2008 Velocity conference. But the idea that you start out with just enough operating system and you incrementally build. The beauty of that is it's repeatable. The negative of that is it's not immutable. How you built it on your laptop, how you built it in CI, how you built it in QA, how you built it in production could be variant. There's so many variations. I spent a lot more time in this in that white paper of showing examples of variation at certain stages. If I'm building infrastructure like line by line by line by line to build, and it all started with kind of a just enough operating system, there are some pitfalls. And then, along that we had the bake versus fry argument. Again, the fry argument is really strong, except if you don't have good image hygiene. Because the fry is turn it on, it's up, it's where it's supposed to be. Right? And I like that, right? That's really clean. But again, in general, like Amazon, the whole Amazon image sprawl problem in the original cloud, right? In fact, I remember, an upcoming slide is the Netflix case study. I think it was back in 2011, they wrote a blog article about building infrastructure as Legos. And everybody in the infrastructure as code camp went, oh my God, you cannot do that. You're using golden images. That is horrible. And I was fortunate to go sit down with Adrian Krakoff in Los Gatos for a day because we were actually having another argument, which was DevOps, no ops. and I got to see how they did infrastructure, and they had good hygiene. And it like the Fry model or the immutable, Israeli immutable infrastructure model works really well if you've covered your bases. So in their world, this is pre-Docker or pre-kind of container explosion. They basically built the building of the image into the CI/CD process. So the source code for the AMI was in Git. They did a pull request that went into integration. The output of that was an AMI image that went into Nexus or Artifactory, one of the repositories. And then at any provision time, you pulled the latest and greatest version. Like, it's how we do source code, right? It's treating infrastructure the same way we do. So, in fact, this is where I'll get really in trouble. Chris Brown's up next, and he's probably fuming back there. We're best friends, but I will say that infrastructure as code is not really infrastructure as code. You think about what we do with code. We compile the artifact, we put it in there, we pull all the binaries. We don't compile it at runtime. Infrastructure code implementations are just-in-time compilers, or because we are really building it on the fly as we're implementing it. And then we have containers, right? So with 3 minutes left, hey, containers. The thing about containers, and I will say in general, Docker has some properties that are a little bit, add some sauces. So Docker is not just Linux containers, right? It's a whole bunch of other secret sauce around, not secret sauce, but sauce around how you deliver a container, right? And there's some properties of containers in general that they're instantiated, because they're processes. They don't really have a hypervisor. They rely on the host. They share the host operating system. They instantiate in 500 milliseconds as opposed to maybe 2 minutes, 3 minutes, whatever. They don't necessarily, it's an operating model, rely on a kind of a convergence of how to connect multiple services. They just kind of build in and use service discovery. So in general, people who work with containers in service-oriented structures like microservices literally tend to build their infrastructure in about 2 or 3 seconds. So a multi-service stack, most of that because the instantiation time of a container comes up. But the other thing that Docker does well is they borrowed some other things that aren't just kite containers. They borrowed union file systems and using a copy on write model. So now you have these kind of binary artifacts. So the net of this story is people who deliver immutable infrastructure with Docker will build their service infrastructure on their laptop, typically on one VirtualBox machine running, say, Vagrant, maybe 5 or 6 services, one of the services they own, the 4 others they don't own. They test that. If they have to retest, their rebasing of that complete service is a couple of seconds. No 8-minute, 15-minute, 20-minute context switches. And then they deliver that to the CI process as mutable binary artifacts. If that goes green through that process, they get delivered onto production as immutable binary infrastructures. And basically, bit for bit, you have a congruent infrastructure. And I call it immutable delivery, not immutable infrastructure. And I don't have time to do this. I have a 3-port blog article on the Docker thing where I go into detail, where I cover a lot of what's in Gene Kim's Phoenix project, the 3 ways of DevOps. I will say that this book has enlightened me. I'm a big Deming fan. It's called Supply Chain Management. There's a lot more to the story than I can tell you in 1 minute. But I use the velocity, variation, and visibility as my argument for why Docker and the 3 ways of DevOps works really, really well. And I've talked most of it. The velocity is the speed at every layer, speed of production when you're basically rebuilding a cluster. If you had to wait for every node for 3 minutes or 8 minutes, as opposed to like 1 second or half a second. And variation, I think I've explained that reasonably well. Order matters, that paper. And I told you about the Netflix case study. They weren't using Docker, they were using Amazon, but they're now I've heard a lot of their stuff is muting. This is a great story with 25 seconds left. At DockerCon 2014, Michael Bresnak basically gave this presentation about immutable infrastructure. And here's what he said at this point of the slide, 2804. He said that now in our infrastructure, basically, when our developers check in their code, it's like 4 or 5 binary artifacts with 1 meta file, and that goes through the system. Before that, our infrastructure was a wasteland of thousands and thousands of release engineering scripts that were built by people in all parts of the organization, some people that might have been dead. He didn't say that. But the point is, it was a wasteland between dev and ops. Here's the references, and I have 0 time, so we'll make this the slide deck available. And thank you very much.